Let's see problems on linear equations. First question, solve dy by dx plus y by x into log x is equals to sin 2x by log x. The given equation is dy by dx plus y by x log x is equals to sin 2x by log x. Now the coefficient of dy by dx is already 1, so no need to divide by anything. So it is in the form of dy by dx plus p of x into y is equals to q of x. We know that p of x and the q of x are the functions in terms of x variable. So here q of x, this function is already in terms of x variable, and here p of x is in terms of x variable, that is 1 by x log x is the p of x and into y. So p of x is 1 by x log x and q of x is sin 2x by log x. So now integrating factor will be e power integration of p of x into dx, that equals to e power integration of p of x is 1 by x log x dx is equals to e power integration of, this can be 1 by x log x can be written as 1 by x divided by log x by 1 into dx. So we are assuming log x as a function t. So because we cannot directly get the integration of this, so that's why any one variable we can find it, we can take it as a one variable. So here I am taking log x as a t. So when we take it t, now we have to differentiate it on the both sides. When we differentiate log x, we get 1 by x dx, and here when we differentiate t, we get dt. So that is like log x differentiation is 1 by x into dx. Here if you see dx, derivative of log x is 1 by x. So log x is equals to 1 by x into dx. So this will be the here. Then log x can be written as 1 by x into dx is equals to dt. So now e power integral 1 by t dt. Here we are writing the log x as a, 1 by x into dx as a dt, and then log x as a t. So e power integration of 1 by t into dt. So that equals to, now integration of 1 by t is log t. So that equals to, we know that e power log x power n can be written as x power n. So here x nothing but t, so t power 1 nothing but t. That equals to, we assume the t variable as log x. So t is equals to log x. This is a integrating factor, that is log x. So integration of e power 1 by x divided by log x, nothing but e power integration of 1 by x into log x dx is log x. So we have to assume any one function as the variable t. So when we differentiate the log x, we get 1 by x. Then we can find out the general solution. General solution is y into integrating factor is equals to integration of q of x into integrating factor dx plus c. So y into integrating factor is log x, that equals to integration of q of x is sin 2x by log x into integrating factor is log x dx plus c. So log x will be cancelled here, then you get y log x is equals to integration of sin 2x into dx plus c. So y log x is equals to sin 2x, integration is cos 2x, and 2x should also be written in the denominator. So by the formula we have sin 2x integration is minus cos 2x and divided by the constant 2. So y log x is equals to minus cos 2x by 2 plus c is the general solution. Then next question, solve cos square x into dy by dx plus y is equals to tan x. So now it is not in the form of dy by dx plus p of x into y is equals to q of x. So to make into that form, we have to divide the dy by dx, we have to divide this whole equation by cos square x. So when we divide it, we get the coefficient of dy by dx as 1. So now divide with cos square x on both sides. So when we divide it, dy by dx, cos square x by cos square x is 1, and here 1 by cos square x into y, that equals to tan x by cos square x. So remember that we are dividing cos square on the both of the sides. So tan x by cos square x. Now we made the coefficient of dy by dx as 1. So now it is in the form of dy by dx plus p of x into y is equals to q of x. When you see on the right hand side, this whole function is in terms of x, and here p of x is 1 by cos square x into y. So it is in the form of this. Then from this equation, p of x is 1 by cos square x, and q of x is tan x by cos square x. So we know that 1 by cos square x can be written as sec square x, and here 1 by cos square can be written as sec square x. So we are changing into secant square x because integration will be very easy. So now we have to find out the integrating factor, that equals to e power integration of p of x into dx, that equals to e power integration of p of x is secant square x into dx. So sec square x integration is tan x. So e power tan x is a integrating factor. Now we have to find out the general solution. General solution is y into integrating factor is equals to integration of q of x into integrating factor dx plus c. So y into integrating factor is e power tan x, that equals to integration of q of x is tan x into secant square x, and integrating factor is e power tan x into dx plus c. So now we are assuming tan x as a t. So when we assume tan x as t, then tan x integration will differentiation will be secant square x. So we can take the tan x as a t. So the tan x is equals to t. So when we are assuming any function as a variable, the differentiation will be in the same function. So by that we have to assume the variable. So tan x is equals to t. When we differentiate the tan x, we get the secant square x. So tan x is secant square x into dx is equals to dt. So now from this, y into e power tan x is t is equals to integration of tan x is t, and here secant square x into dx, it can be written as dt. So here t into e power t and secant square x into dx is dt plus c. So we know that formula, integration of uv dx. It means the two functions are present. We can use this formula, that is derivative of u into integration of e minus double derivative of u double integration of v plus single integration, then plus u double derivative of the function u into triple integration of v. So here we are assuming the function t as u and e power t as v. So here y into e power t is equals to first u dash, that is derivative of here we get only u, then t, that is u is t, and integration of e power t is e power t minus derivative of u. So derivative of t is 1 with respect to t, that is 1, and double integration of v is e power t. When we integrate it, again we get e power t only, plus double integration of double derivative of u. When we differentiate it 1, we get it as 0 because it is a constant. So whatever the terms we get here, then it is multiplied with 0, then the whole answer will become 0 plus c. So y into e power t is equals to, from these both terms we can take e power t common. So e power t of t minus 1 plus c. So at last you have to substitute the value of t. When you substitute the value of t, that is tan x, then you get y into e power tan x is equals to e power tan x of tan x minus 1 plus c. This is a general solution of this equation. Let's say the another form of linear differential equation of first order. In previous one we have solved problems on the form dy by dx plus p of x into y is equals to q of x. So here we are we will have dy by dx and the function p and x in terms of x variable. But here in this method, everything will be changed here. Which we are having dy by dx, here we will have dx by dy, and p of x and q of x are replaced by the p of y and q of y. So it means the functions p and q are in the variables of y, and here y is replaced by x. So it is dx by dy plus p of y into x is equals to q of y. So at the time integrating factor will be e to the power of integration of p of x into dy, where in the previous case we was having the integrating factor as e to the power of integration of p of x into dx. And here general solution will be x into integrating factor is equals to integration of q of y into integrating factor into dy plus c. In the previous one we was having y into integrating factor is equals to integration of q of x into integrating factor into dx plus c. So let's solve two problems on this method. Let's see the first question. Solve dx by dy minus x by y is equals to 2 into y square. Or it can be, the question can be asked like x plus 2 into y cube dy by dx is equals to y. So in this no need to confuse by seeing this question, we can change into this form. Now it is in the form of dx by dy plus p of y into x is equals to q of y. So from this p of y is minus 1 by yx, minus 1 by y, and q of x is 2 into y square. Here the function is in terms of y variable. Then integrating factor will be e to the power of integration of p of y into dy. Then e power p of y is minus 1 by x into dy minus constant 1 by y integration is log y, that equals to e power minus log y, that can be written as e to the power of log y to the power of minus 1. Then that equals to y to the power of minus 1. Y power minus 1 can be written as 1 by y. So this is the integrating factor. So when the question is given like this, you can you think that dy by dx means we have to use the first method, but when we multiply this inside function to the dy by dx, then the question will be changed here. So at first we have to make the coefficient as 1. So when we make the coefficient as 1, we have to divide the x plus 2y cube on the both sides. So when we divide, we get dy by dx is equals to y by x plus 2 into y cube. So dy by dx, send y by x to the left hand side, you get minus y by x, that equals to 1 by 2y square. So y by 2y cube, y will be cancelled, then the leftover is 1 by 2y square. So when we do the reciprocal of it, we get the dx by dy minus x by y is equals to 2y square. Now this is in the form of the question. So dx by dy minus constant is 1 by y, p of y is 1 by y, and 2y square is the q of y. So now we got the integrating factor, we have to find out the general solution. Now general solution is equals to x into integrating factor is equals to integration of q of y into integrating factor dy plus c. So x into integrating factor is 1 by y is equals to integration of q of y is, we got the q of y as 2 into y square into integrating factor is 1 by y dy plus c. So now x by y is equals to, y will be cancelled, then integration of 2y dy plus c. So x by y is equals to 2 constant, y integration is y square by 2 plus c. Here 2 will be cancelled, then you get it as x by y is equals to y square plus c. You can even leave like this, or multiply this y to the right hand side. Then it becomes x is equals to y cube plus c into y. Then second question, solve 1 plus y square plus x minus e power tan inverse of y into dy by dx is equals to 0. So now the given equation is this, and here send this term to the right hand side, then it becomes 1 plus y square is equals to minus of x minus e power tan inverse y into dy by dx. Now send this dy by dx to the left hand side, then it becomes dx by dy. So 1 plus y square into dx by dy is equals to minus x, minus into minus is plus, e power tan inverse of y. Now we have to make the coefficient of dx by dy as the 1. So we have to divide by 1 plus y square. Before that, send this minus x to the left hand side, because all the y terms has to be in the right hand side and x terms has to be in the left side. So when we divide with 1 plus y square, this coefficient of dx by dy becomes 1, and here we get x by 1 plus y square, and right hand side we get e power tan inverse of y by 1 plus y square. So that is dx by dy plus 1 by 1 plus y square into x is equals to e power tan inverse of y by 1 plus y square. So now we made the coefficient of dx by dy as 1. So now it is in the form of dx by dy plus p of y into x. So this is a p of y function in terms of y variable into x variable, that equals to the q of y function. We have this function in terms of y variable. So from this, p of y is 1 by 1 plus y square and q of y is e power tan inverse of y by 1 plus y square. So now we have to find out the integrating factor. So we know that integrating factor is equals to e power integration of p of y into dy, that equals to e power integration of p of y is 1 by 1 plus y square into dy, that equals to, so integration of 1 by 1 plus y square is tan inverse of y. By the formula we have it. Now integrating factor is e power tan inverse of y. Now we have also find out the general solution, that equals to x into integrating factor is equals to integration of q of y into integrating factor dy plus c. So x into integrating factor is e power tan inverse of y is equals to integration of q of y is e power tan inverse y divided by 1 plus y square into integrating factor is e power tan inverse of y to dy plus c. So we are assuming that tan inverse y has a t, because when we differentiate the tan inverse of y, we get the 1 plus y square. So tan inverse of y is equals to t. Now differentiation of tan inverse of y is 1 by 1 plus y square into dy. Into dy we get, because we are differentiating with respect to y. Then that equals to t differentiation is dt. So then we get it as x into e power t, because tan inverse of y is t. So x into e power t is equals to integration of e power t into e power t, and here 1 by 1 plus y square into dy. 1 by 1 plus y square into dy can be written as dt. So finally we get x into e power t is equals to integration of e power t into e power t into dt plus c. So that is what I have written here. X into e power t is equals to integration of e power t into e power t dt plus c. So x into e power t is equals to e power t into e power t is e power 2t into dt plus c. Now x into e power t is equals to, we know that integration of e power ax into dx is e power ax by a. So where a is a constant here. So here a is 2. Then integration of e power 2t is e power 2t divided by 2 plus c. So x into e power tan inverse of y. Now we are substituting the value of t. So t is tan inverse of y. Then that equals to e power 2 into tan inverse of y by 2 plus c. So multiply this 2 to the left hand side, we get 2 into x e power tan inverse of y is equals to e power 2 tan inverse of y plus c. So this is a general solution.